TepiTool. So it's a new interface for the prediction of class 1 and class 2 epitope candidates. So we have now, right now we have class 1 and class 2 tools separately. So what we designed a combined interface for both the class 1 and class 2. So the motivation was that we wanted to make it more user friendly, and we wanted to provide all the recommended threshold values, and at the end results, instead of providing like all the prediction values for like as a single file, we thought like, okay, we'll provide the top peptides based on your input parameters. And so this is designed as a step-by-step wizard kind of tool. It involves 6 steps, and it provides the recommendations as default values, and the input parameters which are given us by default can be adjusted as your need. And the new methods that I explained just a few minutes back, like the 7 allele method, all those have been incorporated into this one. So we have submitted this paper, so right now it's under review. So once it's published, the tool will be available at this link. So the class 2 tool is tools.idb.org MSc2. So instead of MSc2, TepiTool. So the tool will be available at this link. So right now I'll just give you a preview or a quick tour for this tool. So here you can see the interface. So this is the basic design is same. At the top you can find all the different tabs for help, reference, download, contact, and you have got 6 steps here. So at the first step you provide the sequence, your sequence of interest or peptides of interest, and you have 2 options. Either you can copy paste the sequence or you can upload the sequence file here. And once you have your sequence ready, you go to the next step, and the second step you choose the species and allele class. So it's same as before. So here you have the option to choose from 7 different species, and for human and mouse you have the option of choosing between class 1 and class 2. For all the other species you have got only class 1. And once you do the selections, the current selections are shown at the right side panel, and once you have your selection done, go to the next step, and here you have the option of specifying the alleles. So here we have chosen human class 1, and now at the first option provides a list of alleles that are mostly frequent or frequently occurring alleles. That's frequency greater than 1% in the global population. And the second option will give the option of choosing from any of the alleles available for which we have algorithm available. And the third option is select from list of representative alleles from HLA supertypes. So we have a set of supertypes defined. So this is a representative from supertypes. And the fourth option gives automatically selects all the most frequent alleles, the set of 27 most frequent alleles. So you click that, it's automatically selected. And the last option is upload allele file. If you have your own custom list of alleles, you can upload that here, just same as what we have right now. So right now let me select 2 alleles. So you can do the multi-select here. And going to the next step. So in the next step we can choose the number of peptides. So select peptides to be included in the prediction. So the first one is apply default settings for low number of peptides. So that means here we are removing all the duplicate peptides. So if you have multiple sequences, same duplicate peptides are repeated, these duplicate peptides will be automatically removed, and only peptides of length 9 will be included here. And this shows how many 9mers are included in your sequences. And if you want a little bit more peptides, you just select the moderate number of peptides, which gives automatically, like it selects 8 mers, 9 mers, 10 mers, and 11 mers. And if you want more, it selects all the lengths from 8 to 14, and duplicate peptides will not be removed. And at the end, you have custom selection option of choosing custom selection, like you can select what all lengths you want, and if you can choose whether you want to keep or remove the duplicate peptides. And at the end, there's another option of conservancy analysis. So you have multiple sequences, and you want to have the results, the peptides in results that are conserved in only specified percentage of sequences. Then you can check this one here, and you get this option. So if you want to have peptides that are conserved only in 50% of sequences, you can choose this and select how many sequences you want. So I choose to have the conservancy analysis, and I want to use only peptides that are conserved in at least 50% of sequences.
A question: when it's showing the equals, is that in real time telling you how many 8 mers, 9
yes,
mers, 10
exactly.
mers?
Yes,
Okay.
from your sequence.
Okay.
So the next step, 5th step, is where you select the method. So as of now, like now, we have all the methods available here. By default, we have the IEDB recommended. And for selecting the predicted peptides, we have different options as well. So for example, by default, what we recommend is to use the predicted percentile rank and the threshold of 1. So this will automatically select all the peptides that have percentile rank less than or equal to 1. So if you want to adjust that, like make it 5, you can do that. And the second option is select peptides based on predicted IC50. So you don't want to use the percentile rank, you want to follow the IC50, you can do that here. And by default, the recommended value is 500 nanomolar. And if you want to make it 1000, you're free to do that. And the next one is peptides based on MSC specific predicted binding. So we published a paper in 2013 in Journal of Immunology. So we found that if you use allele specific predicted binding affinity, that may be slightly better, than going with the predicted percentile rank. So we have these predicted affinity, the allele specific predicted affinity values only for this set of alleles. So if you are using this predicting for this set of alleles, so we recommend using this one. Select peptides based on MSC specific binding threshold. So, so for more details are given in the help page. So for each specific editor showed that in one slide. So for each allele there's MSC specific, allele specific binding affinity threshold.
Sorry, another question. Is that, or 2 questions, is that the list of the 26-7?
No, this is not that.
This
is where we can employ this method.
Okay.
So for a set of different alleles, we have got this threshold, MSC specific binding affinity threshold. We calculated that.
Okay.
So for this set of alleles, you can use this method. So but if your allele is not here, you cannot use this method.
Yeah. And can this tool handle doing simultaneous MHC1 parameters and MHC class 2 parameters? So where you're using the IC50 threshold of 500 for...
So that's for class 2, it's a different path. I will show you that.
Okay. So when you use this recommended, allele specific binding affinity threshold, this is for, corresponding to 75% of the immune response. So more details is given in this paper, 2013 paper. And the last, and other options are like, if you want to get 2%, top 2% of the peptides, so you have like 250 peptides and I want to get the top 2% of peptide, you can do that here. So for example, I want to get 5% of peptides, so it will automatically calculate here how many peptides you will get in the result. And similarly, you can specify the number of peptides. So I don't want to estimate the percentage, I just want top 50 peptides. You can specify that here, like that. So for now, let me choose the first one and let me select peptides, cutoff value 5. And now we go to the last step. Here you get all your input parameters. You can review that. Number of sequences 3, species human, class 1. These are the 2 alleles, and peptide length selected 9 mers, 10 mers, and peptide overlap. This is not applicable to class 1. It's only applicable for class 2. And conservancy analysis, you want to do the conservancy analysis, and you have set the threshold of 50% of sequence. And the prediction method you're going to use is IEDB recommended, and peptide selection is based on predicted percentile rank, and cutoff is 5. And here there are 2 optional things. You can give a job name. So it's better to give a job name, because if you have some issues and you want to contact us, and if you can include that job name, it will be easy for us to track down, okay, what happened wrong. And then there's an option for providing the email. So if you provide your email ID, once the job is done, sometimes if you have more sequences, it may take long, so you don't have to keep waiting. So once if you provide the email ID, there will be an email sent to your inbox that the task is done, and it will have the top peptides that's predicted. Once you have everything ready, you submit. So this is the results. So at the top, you can see these are the concise results, or these are the top peptides according to that we selected based on your input parameters. So you have 2, 3, 4, 5, 6 peptides that are below consensus percentile 5, and that are conserved in more than 50% of sequences. And if you can download this table here, clicking this link, and in the next section it shows the complete results. So that's what you get right now. And in the next link, this link is for conservancy of peptides. So let me download. Opening. Okay, I'll show you that. Yeah. So this is the complete result. This is what you get right now. So using the tool that we have right now, this is the complete result. So in case you want to check the complete prediction results, you want the results binding prediction for all the peptides, you can download that using this link here. And the conservancy, and this is the conservancy. So this shows for each peptide in how many sequences this is conserved 100%. So this shows the sequence number and the peptide start and end positions, and whether it's conserved. Conserved means it's 100% identical. So as of now, we don't have the option to blast or finding similar peptides, but 100%. So this peptide is conserved in 2 of the 3 sequences that I provided. So it's 67%. You have the option to download that. And the third section is citation information. So you need to cite these papers in case you are using these results. And the fourth section is input sequences. So these are the 3 sequences that I provided, and other input parameters if you want to cross-check. So right now you saw the class 1, and let's see how you can do the same for the class 2. So here in the second step, I'm choosing class 2, human class 2. So the options are slightly different for class 2. So at first you have this. In the third step you can choose the alleles. And the first one is predict for custom allele set. So you can choose your alleles from the by default sets. So these are the most frequent alleles. Select from list of alleles, or you can do upload allele file, your own allele file, same as what we have right now. And so you can choose for DR, or you can do multi-select or DP, like this. And if you want to choose alpha and beta chain separately for DP, you can do that here, like this. And if you want to reset alleles, you can click here. So right now, let me just choose a couple of alleles from here. Okay.
So, and the second option available are predict for pre-selected panel of alleles. So for example, here's the most frequent 26 alleles. If you want to do the promiscuous binder prediction using the most frequent 26 allele, you can use this one. And you can either select all the DR, DP, DQ, or if you want only one set, then you can do that here. And the third option is predict using pre-selected allele sets and methods. So this is where you can use choose the 7 allele method that I explained some time back. So you click this, automatically it will do everything. So you don't have to do anything manually, and use 7 set of 26 most frequent alleles. So you use this for doing the promiscuous binding prediction using the 26 alleles. So let me choose this one here. So similar to the class 1, there are different options for inclusion of peptides. So by default, apply default settings for moderate number of peptides. So what changes here is the desired number of overlapping residues. So by default, it's overlapping by 10 amino acid residues. So if you set it as low, it will change as number of overlapping residues at 8. So this number will reduce. Like previously it was like 12, it changed to 8. And then if you want high number of peptides, this is increased. This is kept at 10, but it will include the duplicate peptides. And you can choose the conservancy here. And similar to class 1, you have the option to choose your method, and different options available. It's also same as class 1 based on predicted percentile rank. Select peptides based on IC50, and you can adjust the threshold here. By default it's 10, that's what we recommend, and IC50 is 1000 for class 2. And here one option is select peptides based on number of alleles binding. So this is something that we don't have in class 1. So if you are doing the promiscuous binding prediction, so this is the option that you can use. So you have a set of 10 alleles, or you choose the 26 alleles reference set. Then you can select the peptides based on predicted number of binding alleles, and you can adjust the threshold here. And these two options are same. You can choose the percentage of peptides that you want or number of peptides that you want. So let me keep it here. Let me make it 15. This is the result. So it's also same as class 1, and one difference here is that the only difference here is that you get an additional table here, non-redundant results or prediction results with redundant peptides with each sequence removed. So that's for this tool, the new TepiTool, we are using the post-processing. So I mentioned for removing the redundant peptides, we can use pre-processing or post-processing. So here we are using post-processing, so that just to make sure that we always capture the best predicted peptide. So that table actually provides all the peptides after removing the redundant peptides. And
so question for you about this TepiTool. So am I understanding correctly that if you wanted to do the promiscuous binder identification, you don't have to do it manually? It will output that directly?
Yes.
Oh, that's awesome.
Yeah. This is the email that you'll be getting. So once the job is done, you will get an email, and it will have the concise table. And it will also include, it's not implemented right now, but it should include the links for downloading the complete table. Yeah, and yeah, this is what I wanted to show you. So this is the This is the non-redundant result. So that when you click that link, you get the post-processed result. So this is how it works. So I showed this slide before, but it picks the top peptide and eliminates all the redundant peptides from the same regions.